Okay, so there are the answers through for 1 through 7. Can I scroll up?
No.
Okay. Question?
For number 3, why would it be to the negative?
I really don't want to answer the whys yet. I just want you to see what the answers are, and then I will stand up and I'll go into any why you want to go into. But at first, I just want to get I want you to see if you're right or wrong. Okay? I hope you realize in number 5 that the f is the same exact function as the f of x here. Okay? That's why it says if the domain of the function f of x above, find the range. Okay? I certainly hope number 7 was easy for everybody. Number 8, God bless. I want to talk a little bit about number 10 and the way to express your answer. It's a little confusing the way I worded it. It says, which graph models an exponential function, and the second graph is quadratic. So you have to write them in that order. So what I'm really testing is if you can recognize both an exponential and the quadratic. So D is exponential, A is quadratic, and it needs to be written in that order, D then A. Okay? Oh, so now it decides it's going to do two-sided. Strange. Okay, there's the graph. And I've mentioned to you several times that it's really important to put the table down. I expect to see the table anytime I see the graph, because when you do a graph, you plot the coordinates you find in the table. You do not do a quick general sketch of the graph, unless it says sketch. But when you actually draw the graph like we're doing here, and they give you coordinate areas, you are expected to write the coordinates down. Yes?
For the zeros, does it matter what order you put them in?
No, it does not. Traditionally, Chloe, we kind of go the negative, or the smallest one first, and then the next one, like number order, but it's really not a big deal if you don't do it that way. You'll notice the way I wrote the answers to the zeros, it does not look like a coordinate. I don't want to write my answer so it looks like a coordinate, because then maybe the teacher does something stupid. I told you about my friend out in California who just has this teacher who is just a jerk. And literally, the teacher cackles when she tricks kids on questions. She likes tricking kids. She somehow gets a sense of self-worth out of tormenting. And these aren't kids. These are 30, 40, 50-year-old people that she's doing this to. Don't say they're old either, because we're not old. But she would, that's the kind of teacher who would look at something like -4, 2 and think that, oh, she must mean a coordinate, so it has to be wrong. And then you couldn't even talk to them about it. When you take your Regents exam in June, I do not grade it. By law, I'm not allowed to grade it. It's these laws that they make. It's insane, but it is what it is. Or they assume that I'm dishonorable.
Then why do they give you a job as a teacher?
That's a
That makes
great
no
question. I
sense.
wish you would ask Governor Cuomo that. Now, so the bottom line is that the teacher who grades your test will not be me. So if you write something that that teacher's not used to and could misinterpret, it could be just an honest mistake by that teacher. And I don't want you to put a teacher in a position to make that honest mistake. In softball, there's this rule in softball and baseball that if you get hit by a batted ball in fair territory, you're out. So, well, for the most part. So we teach our girls when they come over third base to make sure they're in foul territory. So if you're hit by the ball in foul territory, it's only a foul ball. And we teach them to be well into foul territory, like 2 or 3 feet. So the umpire cannot possibly screw up the call. We don't want that to happen to you here. Now, I do want to discuss, well, you know what? I'll get to that a little bit later. All right. Here's the one for an exponential graph. And first take a look at your graph. I don't want to talk too fast here. Okay? Now, the part that concerns me, I remember grading a question that was similar to this last year. And what I remember, do you see the work on the side that talks about the slope or the rate of change? I remember a lot of kids not doing it. Did you do it? Or did you not do it?
I didn't see it.
I think a lot of kids didn't even read it. You see how I circled underneath the table where it says find the average rate of change over the interval? I think a lot of kids missed that last year. I don't think they skipped it because they couldn't do it. I don't think they skipped it because they wanted to skip it. I think they skipped it because I did a really bad job of how I wrote that out. So I wanted to emphasize to you that you are expected to show the average rate of change and make sure that you're ready for that so you don't forget to do it on the test, okay? Yes?
Is it okay if we don't write in decimal form?
If it was correct, yes, but here's my problem with that. You can't possibly be more correct. But a lot of times kids make mistakes. For example, the correct answer to this in decimal form is 8.6 repeating. Many kids will put 8.7. They're wrong. So why take that step? Also, this is a slope, right? Isn't it true when you do a slope, you count up, over? So isn't a fraction an advantage when you do a slope? You follow what I'm saying on that? So if your conversion to a decimal is correct, you would definitely get credit. But I think it's dangerous, so I would try to avoid it. But I know your elementary teachers hated fractions and they wanted you to do decimals, everything decimals, and now you're much more comfortable with decimals. So one of my jobs this year is to get you to be calm and chill with fractions. Okay, next up. I want you to notice a couple of things about this graph. First, I want you to notice that I labeled. If you don't label, you lose points. So make sure that you label. The second thing I want you to notice is that I always like to make it a point to write the coordinates at the end of the graph. You do not have to do that, but what's cool about it is if you make a mistake, it will, when you do the rate of change part of this question, you will be able to get full credit for that part, even if you made a mistake on graphing it. Okay? And here's the answers to the rate of change and the time, 8 a.m. Okay? And I think that's it. Okay, that is it.
Is that 14?
Yes. Again, if you put 1.4, that would be okay, but I don't see the need for that. Yes? 705 is good, yeah. Okay? All right, so let's go back to the first page, and are there any of these that you would like me to be a little more specific about and go over a little bit more? Lena?
For number three, why did you put -8 as the exponent?
That's not an exponent. I'm trying to fit it in between number 3 and number 4, so I just wrote it a little bit higher.
Oh.
Okay?
But I think we did that, and somehow we got like, -15.
Well, what I did here,
Wait, do you have to do the parentheses in the calculator like you were?
again, here's the deal with negatives and parentheses in the calculator. If ever you have a negative and you put it in parentheses, you will never, ever, ever get the answer wrong. But you don't always need the parentheses. So as a matter of safety, particularly if you're not comfortable with negative rules, I suggest kids use the parentheses. Okay, so what I did here was this. I plugged in a -2, so I put it in parentheses, plus 3 times -2. And I wrote the -8 up top here because I couldn't fit it. But it would be best written this way. If it's in parentheses, -2 squared means -2 times -2, which is 4. 3 times -2 is -6, and another -8. 6 negatives and 8 negatives are 14 negatives. That's the commutative property, switching order there, which is allowed with multiplication. And 4 and -14 and -10. Or you could just put it into the calculator exactly as it appears and the answer will pop up. Make sure you use parentheses in the calculator. More questions? Anything else? Well, I have a couple that I want to do. I want to go to the graph because, oh, first, before the graphs, I want to go to the rate of change question. All right, here we go. Oh, there's no rate of change answer or question here. Oh, that's rotten. How come that one didn't show?
Oh, the number 12?
Yeah. Why didn't that one print out?
It's on the bottom.
Maybe I might have turned it upside down. All right, so what I'm gonna do is scan it right now and show you the answers.
Also for D in part 2, if you
Okay.
don't have anything.
Hold on, let me just scan this very quickly and get my glasses on here. System preferences. Scan. And in just a second, we'll be able to get this one going here. I have ideas of where I anticipate you guys having difficulties, and I want to make sure that you're well aware of what's going on. While this is scanning, you do realize the test tomorrow is going to look just like this. If there's anything that you cannot do on this pretest, then you will not be able to do it on your test, and that would be trouble. So we want to make sure that you can handle every one of these kind of questions, okay? As such, let's start with this. The first question, y equals 5x plus 1. This is asking for the average rate of change of each of these questions. You know, the other day I did letter A by plugging in coordinates, but you can actually do it much easier than that. What's another name for rate of change? Everybody?
Slope.
Slope. And isn't A in the form y equals mx plus b? So what's the slope? 5. Done.
Oh, that's so easy, okay.
So to me, that's the easiest way to get this done. And letter B, by my experience, I'm willing to bet you guys are pretty comfortable with letter B, because you just write as a coordinate in the table 0, -2, and 310. You plug them into the formula, and you get 12 over 3, which is 4. Do I need to go over letter B? Okay. My experience is that letters C and D are a bit more of a problem. So before I go into letter C, there are some coordinates there for letter D. It's 0, 1 and 4, 3. So why don't you figure out the average rate of change for that particular graph? Zero, 1, 4, 3. So, now, let's take a look and go through both parts C and D in terms of how to come up with the correct answer for each of these. Now, the work for C, I think, is pretty well done up there, and I think that as you follow along, you should be able to do okay. So, with C, g of x is 4 to the x minus 1, which means as I set up the coordinate, I have to see what the y coordinate or output is when the input or x coordinate are 0 and 3. So I plug in a 0 and I get 4 to the 0 minus 1. Look, 0 minus 1 is just -1, so I do 4 to the -1. Negative exponent, reciprocal, that's 1 over 4 to the positive 1, which is 1/4, which is 0.25. if you're not comfortable with that from last year or remembering that, and we'll hit it a little bit again later on, you can always just use your graphing calculator and type in 4, up arrow, or exponent, -1. It'll tell you 0.25. Yes?
And you get a calculator tomorrow?
Yeah, absolutely. It'll be hanging up there every day, okay? Now, so that's where my 0.25 comes from. And then I plug in the 3. 3 minus 1 is 2, so I get 4 squared, which is 16. And then I use these two coordinates over here with my rate of change or slope formula, and it works out to 15.75 over 3. And in this rare case, Kaylee, I did switch to a decimal because there was a decimal already in the fraction. So in that case, I might as well go with it. And the 3 divided in evenly. There was no leftover or repeating decimal I needed to worry about. So it's 5.25. One mistake that I might see with certain kids, some kids might put 5.3. Do not ever round off unless the question tells you to round off. Never. Is there anything unclear about that? Okay, it's just 5.25. Now, this one goes from the point 0.01 to the point 3.4. And that would mean I have 4 minus 1 over 3 minus 0, which is 3 over 3, which is 1. And as far as which one has the greatest rate of change, it would be choice C. The rate of change with choice C is 5.25. B, I think, was 5. A, I think, was 4. And D worked out to be 1. So the greatest rate of change, greatest average rate of change, was C. Okay, any questions? Okay. Let's go now to the question underneath this. And what I have noticed in grading kids who've done questions like this in the past is that they tend to do really well with 3 of them and very poorly with 2 of them. So let's address all of them and make sure we're good. First, when I ask kids what's the domain, I think every kid in the class, in both classes, is going to get that right. The domain is the list of x values. It's 0, 1, 2, 3, 4. There they are. I'm willing to bet every kid in the room got that right. Next one says, what's the range? The range is the y values. It's the set on the right. 38, 64, 90, 116, 142. Virtually 100% of students get those 2 right. One that just about 100%, I'd say 95+% get right, is the 4th one. What's the y-intercept? Kids know that the y-intercept pairs with 0. So they get 38, and just about every person will get that right too, also. Anthony, question?
No, but I was gonna point out one way that you can find what M is. What I did was that I subtracted 38 from 64, then I divided it by 1, and I got 26.
That's an excellent way to do it. Now, that works. One of the things that makes that so excellent, Anthony, is there's 2 ways to go about doing it, buddy. Or that actually shows the 2 ways in one way. And what I mean by that is this. If I want to know the rate of change is slope, agreed? And haven't we found the slope many times already this year, or the rate of change, by using that formula?
Yep,
And to use that formula, don't I need 2 coordinates?
yep.
You guys with me on this? Okay. If that's the case, I can use any 2 coordinates I want. And Anthony, using his technique, chose these 2 coordinates. So this is really the point 0, 38, just another way to write it. And this would be 1, 64. So plugging it in, 64 minus 38 over 1 minus 0, which is 26 over 1, or 26. So that's a great way to do it. It's a little methodical and a little mechanical, but it's an excellent way that will always work. And by the way, you could have chosen these 2 points. You could have chosen the last point with any other point. It doesn't matter which points you choose. It will always work with any points in this. However, there's another way that you could do it. You could look at this and say, look, it's going up by the same amount every single time, which makes it linear, right? Isn't that how we can tell a linear function? The constant rate of change goes up by the same amount every time. So what are they going up by? They're going up by 26s. So since they're going up by 26s, the rate of change has to be 26. Now, in my experience, some kids will struggle a little bit with that. Make sure you're prepared for that kind of question tomorrow. It is coming. There's no deception in me. I don't cackle when kids get things wrong. I get upset when kids get things wrong. I want you to get them right. I don't want to trick you. I want you to know what's coming so that you can do the job that you expect to do. Now, the writing of the function rule is the most difficult question for kids, because it's a little bit awkward, and you have to know the two sections above it to get the last part for the function rule. Look, this is linear. This all depends on you recognizing that this is a linear function because you're going up by the same amount every single time. As soon as you go up by the same amount every time, you know that it's linear. As soon as you know that it's linear, you know that y equals mx plus b applies. And when you write out y equals mx plus b, m is slope, b is y-intercept. So, this question was the slope. It's 26. So instead of m, I put 26. b is the y-intercept. That was this question. I put my 38. So it's y equals 26x plus 38. Okay? All right. I now want to talk for just a minute about the graphs and oh, here we go. Ta-da. All right, so I want to talk about this particular graph right here and the answers to it. Now, I don't remember what the quadratic graph you're going to get tomorrow is, but you will absolutely get a quadratic graph. How do I know that's a quadratic graph?
Because it's square.
Because the lead exponent is squared. Very good. Now, that means as soon as you know it's squared and it's a lead exponent and it's quadratic, you're going to get that parabolic shape, that U. Now, it might be one like this, or it might be one like this, but it's going to be a parabola. Now, from that parabola, I want to know that you can recognize certain things and do certain things. The first certain thing I want to know that you're able to do is put a table in. I want to know that you can write the table out. So you put this into y equals x squared plus 2x minus 8, and then I expect you to go over to your graphing calculator and write out the table. I expect to see the table on the test. If I don't see the table on the test, you're going to lose a point. What did I say?
Better use the table or you're gonna lose.
That's right. Thank you. You're going to lose a point if you don't put the table on your test. Now, from this table and from this graph, I want to know that you can recognize three things. The first is the zeros. Kids are usually awesome at this. It's -4 and 2, here and here. Oh, by the way, when I drew out the graph, I noticed that -9 would not fit the way it was. So if you notice, I made it -2, -4, -6, -8, -10. And by adjusting the scale, the graph fit. You could have done it differently. You could have just extended the graph a little bit below here. Both of them are good. I am not more right than you. You are not wrong. They're both excellent ways to handle a situation. Yes?
I keep typing y equals
X squared.
but it's not coming up. It just says error.
You'll have to show me in a minute.
Okay.
Now, so that's my zeros. My zeros are wherever it crosses the x-axis, or in the table, my zeros pair up with wherever the y is 0. So -4 and 2, -4 and 2. By the way, that makes perfect sense, because another name for the x-axis is the line y equals 0. And isn't this where we find y equals 0? Okay, so it all fits together. This term zeros, 0 where the y is, the name of the line is y equals 0, etc. Now, axis of symmetry. What last year, the year before, the year before, the year before, what kids constantly do is write this. -1. It's x equals -1. The axis of symmetry is not a point. It is not a number. The axis of symmetry is a line. Furthermore, not only is it a line, it's a vertical line. Vertical lines are the only lines that are not y equals. What do all vertical lines begin with? What do all vertical lines begin with, everybody? X equals. Every vertical line begins with x equals. If I were taking the test tomorrow, and I got to this question, and I saw axis of symmetry, I would write x equals before I even attempt to do the question. Because that's the kind of thing that I personally forget, because I tend to make stupid mistakes. I would put that down, x equals. Now, what does x equals you say? Well, I would say that x equals, here's the line that runs right down the middle. And if you look, the next thing I would do is say, hey, here it is. This is where my x crosses the x-axis, or my axis crosses the x-axis, and this would be where x is equal to -1. So the final answer is x equals -1. Bless you. So that's one question that in the past, the answer to that has bothered kids early in the year. As the year goes on, it doesn't bother them. But on this particular test, some kids will miss that question. So be prepared and know, don't make that mistake. Always begin with x equals, because it's an axis of symmetry is a line. A line is never just a number, and it's a vertical line, so it has to begin with x equals. Next up, the vertex. The vertex is also known as the turning point. It's the point where the graph turns around, and it goes from bottom up again. Now, what are the coordinates of that point? Well, I could look at them and read the coordinates, or I can look in my table and find the point that's in the middle. -1, -, the vertex. So a vertex is always going to be coordinates. It's the coordinates of the point where it changes. You have to make sure you write that down. Okay? Are there any other questions about this graph? Okay. Are there any other questions about the pretest? Anything that I didn't cover that you need me to cover? Okay, so here's the deal. This is how I would suggest we go forward, or you go forward. I'm gonna turn you loose in a minute. Don't pack up. Stop packing, listen. I would not just begin the pretest with question 1 and go forward. Whatever questions you got wrong on this, I would get together with a couple of friends, and I would do those questions first. And I would make sure that your answers match your friend's answers for that particular question. And then go back and do the ones you already know how to do. Work on the ones you need help with. Does that make sense, everybody? Spencer, can you resurrect the lights?
Yes.
Thank you. All right. Get to work. And I am going to get ready to put this video up on the internet.
Video? Oh, that video.
Second.
I put a Snapchat.